Hi everyone, this is Chemistry Made Easy. I welcome you all in my channel. Today I'm going to teach you about manganese. This topic is for grade 12 students. The topics to be discussed today in this lesson are discovery, physical features, oxidation states, interconversion of oxidation states, reactions of manganese to ions in solution. Let's start from discovery. Manganese was discovered by John Gottlieb Gahn in 1774. Now, the physical properties of manganese. Manganese has atomic number 25. Its atomic mass is 54.938 mu. Its symbol is Mn. It appears like a silvery white brittle metal. Its melting point is 1519 Kelvin. Its boiling point is 2334 Kelvin. Its specific gravity is 7.4. It is used in making alloys, particularly in stainless steel, as it has an anti-corrosive nature, so it is used in making alloys. Its oxides are used as oxidizing agents, as a rubber additive, and in glass making industries. In addition, manganese oxides are also used as fertilizers and in ceramics as well. Next to physical properties is oxidation states of manganese. Manganese actually exists in the number of oxidation states, but is more stable in an oxidation state of +2, +4 or +7. Let's see the examples of all of these three oxidation states. +2, manganese chloride. In this compound, manganese exists as +2 oxidation state, manganese carbonate and manganese oxide. All of these three compounds, manganese has +2 oxidation state. +4, manganese dioxide. In this oxide, manganese exists in +4 oxidation state. +7, the examples of +7 oxidation state of manganese are KMnO4, potassium permanganate, and manganese oxide. This is another oxide of manganese in which manganese exists in +7 oxidation state. The fourth one is conversion of manganese +7 to manganese +2. As you can see that the oxidation state of manganese is reducing from +7 to +2, so we can call it reduction. What is reduction? Dear viewers, reduction is defined in different ways. Reduction is the gain of hydrogen, gain of electrons, loss of oxygen, or the reduction in oxidation states. So let's see how this manganese is reducing from +7 oxidation state to +2 oxidation state. Here I have highlighted some of the things and I'll tell you about that they are very important. In +7 oxidation state, it exists in intense purple ion. Note the color and the oxidation state. It is very important. +7 oxidation state of manganese exists in intense purple color. That is the manganate ion. You can, if you have seen in the laboratory, potassium permanganate, that is in intense purple color. It is reduced to pale pink manganese 2 ion. So it means that the manganese 2 ion has pale pink color. And how it is reduced? It is reduced by iron 2 ions in acidic solution. So the highlighted terms are very important to note. The +7 oxidation state exists in intense purple color. The +2 oxidation state of manganese exists in pale pink color. And this reduction of manganese from +7 to +2 is done with the help of iron 2 ions in acidic solution. Let's see the half reactions for both manganese and iron. And then we will go for the overall reaction. The half reaction for manganese plus 7 iron is, you can see the manganate ion. Manganate ion has an overall -1 oxidation state and it is converting into manganese plus 2. Actually, manganese here is in +7 oxidation state and it is converting to +2 oxidation state. So manganese is reducing. And the half reaction for iron is, for ferrous ion is, that the ferrous ions are converting to ferric ion by the loss of electron, and this is called oxidation. The overall reaction is written as manganate ions plus hydrogen ions plus iron 2 ions gives us manganese 2 ions, water, and iron 3 ions. You can see iron 2 ions are oxidized to iron 3 ions and manganese 7 is reduced to manganese 2. Now, the question arises that how can you know that the manganese plus 7 has been reduced actually? By the color change. You have noticed above that the intense purple color is that of +7 ions of manganese and +2 ions of manganese has pale pink color. So when the color changes from purple to pink, it means that manganese has been reduced from +7 to +2 oxidation state. Let's go ahead. Now I'll tell you about the reactions of manganese 2 ions in solution. First of all, I want to tell you that in this topic, we will discuss 2 subtopics. Part 1 is the reaction of hexa-aqua manganese 2 ions with hydroxide ions. The first, the reactions of hexa-aqua manganese 2 ions with hydroxide ion. Let's see. The hydroxide ions, hydroxide, we can use sodium hydroxide or potassium hydroxide here, and they are acting as a strong base. What is a base here? We will say that it is a Lowry-Bronsted base. Lowry-Bronsted base is defined as the base which accepts a proton. Now, this hydroxide ion will accept proton from water. As we have 2 moles of hydroxide ions, so they will be accepting 2 hydrogen atoms from 2 water molecules. And you will notice the change in the formula now. This hexa-aqua manganese 2 ion will convert into tetra-aqua dihydroxy manganese. And the important thing to note is it has no charge. It is insoluble in water, so it forms precipitate. Once again, the hexa-aqua manganese 2 ions, by reacting with hydroxide ions, converts into tetra-aqua dihydroxy manganese, and it has no charge. It is neutral molecule, insoluble in water, and it precipitates out. So this is how the manganese, the complex of manganese, the hexa-aqua complex of manganese reacts with hydroxide ions. Here the hydroxide ions are acting as a base. Let's see the color variation. The color variation, very interesting colors. First of all, This hexa-aqua manganese 2 ion is colorless. It is colorless. When it reacts with sodium hydroxide solution, it converts into a brown solution. The color change from colorless to brown. And on standing, if you allow it to stand, the precipitate turns dark brown at the top. Why at the top? Because the with the contact of oxygen, they are in contact with the oxygen, and that's why they are turning dark brown at the top. So the color change is from colorless to brown, and on standing the brown color darkens. The manganese complex changing its color from colorless to brown, and then the brown color darkens on standing. This is how manganese reacts with a strong base like sodium hydroxide. The next part of the reaction is the same hexa-aqua manganese 2 ions are reacting with ammonia solution. The previous one was the base, and now they are reacting with ammonia solution. Let's discuss about the ammonia. Ammonia is a base as well as a ligand. Now we will see that is it acting as a base or a ligand in this reaction. Let's see. The hexa-aqua manganese. Hexa-aqua manganese 2 ions are reacting with ammonia, and it is converting to tetra-aqua dihydroxy manganese, which is neutral, insoluble, and it forms precipitates along with ammonium ions. Now, what you have noticed? What about ammonia? Is it acting as a ligand or a base? You can see that hexa-aqua is converting to tetra-aqua. It means that two of the water molecules have lost their hydrogen. So, where is that hydrogen gone? That is taken by the ammonia. So, ammonia is acting as a base here. It is accepting a proton from water molecule. Two ammonia molecules are accepting two protons from water molecule, leaving behind the hydroxide ions, and so ammonia is here a base. You can see the color variation. The colorless hexa-aqua manganese ions, they are reacting with ammonia solution and converting to brown solution of tetra-aqua dihydroxy manganese. As it is insoluble, so it converts into precipitate, and on standing the precipitate turns dark brown at the top due to the contact with oxygen. So this was the reactions of hexa-aqua manganese 2 ions. First of all, with base, either sodium hydroxide or potassium hydroxide strong base, or with ammonia. And you have learned that both of the reactions are actually same. Product is same, the color variation is same. So both of the reactions of hexa-aqua manganese 2 ions, either with base or ammonia, they are actually same. This was all about the manganese, and in another part of the video, this is the first part of manganese, and in another part I'll teach you about the oxidizing agent of manganese oxides. manganese is either acting as an oxidizing agent in organic chemistry or in titrations. So that part of the manganese we will discuss in another video. For that, uh, you must subscribe my channel and click the bell icon so you will have notification for other videos. Thank you so much. Till then, goodbye. Take care.